So in this video, we're going to carry on with the introduction to combinatorics, permutations and combinations again, but this time repeats are allowed. So first we're going to go through permutations where repetition is allowed. If we imagine we have a safe with a 10-digit keypad, n is going to be 10. That's the number of digits we can choose from. Now we want to choose three numbers. So r is 3. But these three numbers we choose could be 345, 642, but it could also be 779 or 333 because we're allowed to repeat the digits. So in this scenario, we have 10 choices for the first digit, but we also have 10 choices for the second digit and for the third digit because we can repeat the numbers. This means there are 10 times 10 times 10, which is also 10 cubed, different permutations, which is 1000 permutations. As you can see, that is also the same as saying n times n, r times, or n to the power r. And finally, we're going to go on to combinations where repetition is allowed. And I've left this one till last because it is the trickiest to understand. So I'm actually going to explain it in two different ways. So if you just pick the one that makes more sense to you. So in the first scenario, we have 4 buckets of different coloured balls, which means n is 4, and we want to pick 3 balls, so r is 3. Now you have a choice to pick a ball or to move on to the next bucket. So let's imagine we decide to pick a red ball. Then we decide to move, but we don't pick a ball out of the green bucket, we decide to move again. Then we decide to pick a blue ball. Then we decide to pick a blue ball again. And then we decide to move, but we've finished, so we just stop there. So you could write this as red, move, move, blue, blue, move. This means effectively there are 6 different things that you are choosing. You're choosing a ball, a red or a blue, or moving. You could also write move, green, green, move, move, yellow, or red, move, green, move, blue, move. But whichever way you write it, if you're choosing 3 items, there will always be effectively 6 things you are choosing, a ball or moving. Now the things you're choosing from, in this case 6, is going to be equal to r, the number of things you're choosing, in this case 3 balls, red, blue, blue, and also the number of times you move, in this case is 3 arrows, but that is also equal to n take away 1. Therefore, we now write, instead of n choose r, the new n is r plus n take 1, so we write r plus n take 1 r. And usually the equation has n factorial on the top, so it now has r plus n take 1 factorial on the top. And usually we have n take r factorial on the bottom, but that's now replaced by r plus n take 1 take r factorial, and the r's cancel out, so we just end up with n take 1 factorial on the bottom, and we still need the r factorial on the bottom because it doesn't matter in which way the balls are ordered. It's a combination, not a permutation. So now we've explained where the equation comes from, we're going to use it to solve this example. And we end up with 6 factorial over 3 factorial, 3 factorial, which if you can write it out as 6 times 5 times 4 times 3 factorial, and then it's easy to cancel the 3 factorials out. And you can also cancel the 6 with the 3 times 2. So you just end up with 5 times 4, so the answer is 20. And just for the sake of completeness, I've written down all the different combinations you can have with these 4 coloured balls. And as you can see, there are indeed 20. And finally, we're going to go on to another way to explain combinations where repetition is allowed. So in this example, we have 5 letters, so n is 5, and we want to choose 3 letters, so r is 3. Right, so let's assume we choose the letter B for the first letter. We can strike it through because we've used it, but we still have more letters to choose, and it needs to be available for the next choice, so we have to write it again. Then we choose the letter D, so we strike it through, but we still have another letter to choose, and it needs to be available for that choice, so we write it again. Then we choose D again, but this time we don't have to write it again because we've finished with our series. So as you can see here, the number of items we've got to choose from in this case is the original 5 plus the 2 that we had to strike through and write again, which is 3 take 1 or R take 1. So writing the equation out again, instead of n factorial at the top, the number of things to choose from, this time it's n plus r take 1 factorial on the top. And instead of n take r factorial on the bottom, we have n plus r take 1 take r factorial on the bottom. And the r's cancel out, so we just get n take 1 factorial on the bottom. And also don't forget, we still need the r factorial on the bottom because it's a combination and it doesn't matter in which order the letters are. And now we're just going to use the equation to get the answer. So we end up with 7 factorial over 3 factorial, 4 factorial. And if you write it like this, you can cancel the 4 factorials out, cancel the 3 times 2 with the 6. So the answer is 7 times 5, which is 35. So hopefully one of those last two methods resonated with you on how to formulate the equation for combinations with repetition. Don't forget, obviously, that doing examples and questions is absolutely essential for exam success. And I will be following up with some of those videos. So thanks very much for watching. And yet again, if you like and subscribe, I'd really appreciate it. Thanks, guys.